So we got a series circuit. It's got a 9-volt potential difference source or battery voltage source, however we want to say it. It's got a resistor with a 6 ohm resistance and a second resistor with a 3 ohm resistance. They're hooked in series. There's one path for the charge to flow in. Like always, when you're doing a series circuit, the easiest thing to find first is the total resistance. And in series, the rule is you just add up all the resistors. So 3 plus 6. So our total resistance for this circuit, 9 ohms. To find the current, we know the total resistance of the circuit, that's this. We know the total battery voltage, that's that. So we're going to take Ohm's law. I equals voltage divided by resistance. Solve out for I. So we've got 9 volts divided by 9 ohms. Total battery voltage divided by total resistance. We get it 1, and our current's always going to be in amps. 1 amp. So that's one important rule to know about series circuits. To find the total resistance, you add up all the resistors. The second important rule to know is that if 1 amp comes out of the battery, there's only one way for that 1 amp to travel. There's one path. So the current is the same everywhere in a series circuit. So the current through the first resistor is 1 amp. The current through the second resistor, also 1 amp. Current is the same everywhere. That leaves us with the voltages. To find the voltage at each resistor, we'll start here at resistor number 1. We're just going to take Ohm's law, solve it for V. V equals I times R. So at resistor number 1, we have 1 amp and 6 ohms. So 1 amp times 6 ohms. We end up with a voltage at resistor 1 of 6 volts. At resistor 2, we have 3 ohms of resistance, 1 amp of current. So 3 ohms times 1 amp. We end up with 3 volts. The third important rule to know about series circuits, you can go back and check by this. The voltage drop across each resistor should add up to be the total voltage. So 6 in the first one, 3 at the second one, those should add up to be the total battery voltage, which is 9. And in this case, they do. One more thing, if I was to happen to ask you about the power dissipated at a certain resistor, like P1 and P2, remember that to find power, it's voltage times current. So at resistor 1, we can take the voltage of 6 times the current of 1, 6, and the power is going to be in watts. A volt times an amp is a watt. So at resistor 1, we get 6 watts. And at resistor 2, we've got 3 volts and 1 amp, so we get 3 watts. Now notice something else, a way to go back and check it. The power dissipated across each resistor should add up to be the same as what? The power that comes out of the battery to begin with. Take the 9 volts times the 1 amp, you still get 9 watts.
How do you determine the power?
Voltage times current. V times R. All right, I'm going to pause for a second. Good. Parallel circuit, we've got a 12-volt potential difference source or battery, one resistor with 5 ohms of resistance, one with 2. It's pretty obvious from the picture to see why they're called parallel. The 2 branches are parallel to each other. The difference here is that you don't just have one path for electrons. You've got a path this way, but you have another path all the way around that way. So if one of those resistors burns out, this circuit continues to work. It's not like a series circuit where if one thing blows, it's all blown. Here you have more than one path, and those paths tend to be parallel to each other. First thing that I would recommend you do when you're doing a parallel circuit is find the resistance. To do that, you've got to use the 1 over rule. 1 over the total equals 1 over the first resistor plus 1 over the second resistor. So in this problem, 1 over our total is equal to 1 over 5 plus 1 over 10. So let's get a common denominator, 10. And let's make this, instead of being 1/5, let's make it be 2/10. So we add those up. We get 3 over 10. But realize 3 over 10 is not the resistance. 3 over 10 is 1 over the resistance. So we got to flip it. So our total resistance here is 10 over 3. What I would recommend to do next is find the total amount of current that comes out of the battery. And to do that, you're just going to use Ohm's law. I equals voltage, which in this case is the total voltage of the battery, 12. It might be easier to write it like that because we're about to divide a fraction by a fraction. But that's voltage divided by the total resistance of the circuit, which is 10 over 3. Now we know to simplify that, we've got to invert and multiply. So it's going to be 12 over 1 times 3 over 10. Do a little math here and cancel some stuff out. Hoping you see you get 18 over 5 when you do the math. And that's 18 over 5. Our amps are going to come, our current's going to come out in amps. Second important rule to know about parallel circuits. Voltage is the same across every branch of the circuit. So if your battery voltage is 12, the voltage across this branch right here is 12. The voltage across this branch right here is also 12. There's only one resistor on each branch in this problem. It won't be that way always, but in this problem, if this battery is 12 volts, the voltage drop here and the voltage drop here are 12 and 12. So 12 volts, 12 volts. Now what we got to do is find current. And to find current, Ohm's law. So for resistor 1, let me make a little space. I equals V over R. So for just resistor 1, we take the voltage at resistor 1, which is 12 volts, divided by the resistance at resistor 1, which is 5 ohms. Not much we can do with that other than write it down. At resistor 1, our current is 12 fifths, and that's going to come out to be an amp when we simplify our units. And that is a 5. And then at resistor 2, same idea. I equals the voltage at resistor 2, 12, divided by the resistance at resistor 2, 10. That's going to reduce down to 6 over 5. And then finally, the other rule about parallel circuits we need to be familiar with, if you add up the current going through every branch, if you sum those all together, in this case we've only got 2 branches, 1 and 2, those should add up to be the total amount of current that leaves the battery. 12 fifths and 6 fifths add together to be 18 fifths, which is what we're looking for. All right. Let me pause one more time for a commercial break. All right, guys, what we see up here is a mixed circuit. And it's called mixed because this part right here is parallel. But then that parallel part of the circuit is hooked in series with this resistor over here. So it's part series, part parallel. It's mixed. Okay. A little bit of both. Yes?
Do you ever have the series part between the two?
Yes. And we'll get there. This is the simplest case. We'll get to much more difficult cases later. All right, here's where you got to start. And if you'll listen to me on this and get this down, this is easy. If you don't get this first little rule, it's very difficult. The first thing I want you to do is to find the resistance of the parallel part of the circuit. So only worry about the parallel part to begin with. So to do that, I'm going to write it like this. We know when we're finding parallel resistance, we have to use the 1 over thing. So I'm going to say, I'm not going to put R total here because it's not the total. It's just the parallel part, right? So I'm going to say 1 over the parallel part of the, 1 over the parallel resistance equals 1 over 4 plus 1 over 12. All right. Just working on the parallel part right now. So what that gives me, this is 3/12 plus 1/12. So I end up with 4/12. That's 1 over the total, which means the total is 12/4, which is 3 ohms. I'm going to write that up here at the top just so I don't forget that. RP equals 3 ohms. Here's the key step. Once you find that, once you find the parallel resistance, you're going to think of the parallel part of the circuit here as one resistor with a resistance of 3 ohms, hooked up how with this other resistor over here, hooked up in series. And the rest of your calculations will work from that setup. You're going to think of this whole circled part here as one big resistor with 3 ohms of resistance, hooked up in series with a other resistor.
So basically, the only thing that makes circuit changes is just the resistance.
Well, and eventually we're going to have to go back and calculate some things for each branch. But to begin with, calculate the resistance of the parallel part. In this case, it came out to be 3. For right now, think of this whole circled area as one resistor hooked in series with this resistor right here. So to find the total, we're now using series rules. 3 plus 1 gives us the total resistance of 4. Find the total current, just like always. Use Ohm's law. I equals V, battery voltage, 12, divided by the total resistance of the circuit, which we just found to be 4. So total voltage, 12, divided by total resistance, 4. When we do that, we get a total current of 3 amps. Now, this is where we got to think a little bit. We know in series, current's the same everywhere, right? The current comes out of the battery. Starts to head down here. When it gets to this point right here, some of it splits, right? Most of it's going to go which way? The 4 way. Some's going to go the 12 way. But right down here, what happens? It all comes back together, and all the current has to go through here, right? So for R3, or I3, what are we going to write down? 3 amps, right? It all has to go through there. There's no other way. All the current has to go through there. I3, 3 amps. While we're working on resistor 3, let's go ahead and find the voltage of resistor 3. To find voltage, V equals I times R. So at resistor 3, V equals 3 amps, I, times 1 ohm, R. So we end up at resistor 3 with a voltage of 3 volts. Now we got to go back and think about those other two. What do we know about voltage in a parallel circuit? It's the same everywhere, right? It's the same at each branch. What we need to find, there's several different ways we can find it. If we're thinking of this whole circled part as one resistor hooked in series with this one, what's the voltage of this whole part have to be now? It has to be 9. And the reason we know it's 9, the voltage over here is 3. In series, the voltage across each resistor has to add up to be what? The total voltage, which is 12. So if this one over here is 3, then this whole thing has to be 9. Now that's one way we can find it. Here's another way we can find it. Again, we're thinking of this whole thing as one big resistor with 3 ohms of resistance. If we're thinking of that as one resistor, how much current has to go through that thing? If this whole thing here is one piece, how much current goes through it? All of it. 3 amps, right? How do we find the voltage if we know the resistance is 3 and the current is 3? V equals I times R. So 3 times 3, we get 9. That's the voltage if we touched anywhere in this circuit with a voltmeter. 9, it's 9 through the whole thing. What do we know about each branch? In parallel, what do we know about each branch? It's the same. So if the voltage of this whole thing is 9, then the voltage across resistor 1 is 9. And the voltage across resistor 2 is 9. Everything's 9. What that leaves us with, let's see if I can straighten this up a little bit. What that leaves us with are the currents. And to find the currents through each of those two branches, I equals V over R. So at this resistor, which right here is resistor 1, we're going to go I equals, at resistor 1, the voltage is 9 volts. The resistance is 4 amps. So I equals voltage divided by resistance. No way to simplify that. So I equals 9 fourths at resistor 1. And that's an 8, not an O. And then at resistor 2, same setup. I equals voltage. At resistor 2, the voltage is 9. Divided by the resistance at resistor 2, which is 12. We can reduce that a little bit. We can reduce that down to 3/4. Now, key way to check this. These two currents better add up to be what? The total amount of current. Because all the current's got to go through one of those two branches. So 9 fourths and 3/4, 12 fourths, same as our total current, 3 amps. We turn this thing off and we'll get some questions.